All right, question 36 here says, Alex launched the ball into the air. The height of the ball can be represented by this equation, h equals negative 8t squared plus 40t plus 5, where h is the height in units and t is the time in seconds after the ball was launched. Graph the equation from t equals 0 to t equals 5. All right, so we have this quadratic here. I know that's a quadratic, but it's because the t value there is squared. So when we have this parabola type shape, the first thing that's always good to do is to find the vertex, which we're actually going to have to do anyway, as it says to state the coordinate of the vertex and explain its meaning in the context of this problem. So why don't we go ahead and do that here. So we're given this equation that h equals negative 8t squared plus 40t plus 5. All right, to find the vertex, what we're going to want to do is use this equation that, I'm going to say x in this case. X is equal to negative b over 2a. So we're looking for the x value here. Now, in our case, the x value is the same thing as the t value. So why don't we say t actually in this case. All right, so in order to get this, t equals negative b, well, that comes from the equation that's like a t squared plus b of bt plus c. So in this case, I just need to read off b is 40, so this is negative 40, over 2 times a is going to be negative 8 here from just reading off of my function. So then we can solve this out. T equals negative 40 over negative 16. So t is going to equal 2.5. All right, so there's my t value in this case. Now I need to find out what the height is at 2.5. So let's go back down to this equation here. And what I'm going to do is I'm going to go ahead and substitute back in that 2.5 squared plus 40 times 2.5 plus 5. And if you'd like, you can do this all on your calculator. So let me pull up my calculator here. You can just go ahead and type this all in. So negative 8 times 2.5 squared plus 40 times 2.5 plus 5. And you'll get that h is 55. Okay. So our vertex point here, so vertex point is 2.5 comma 55. So that's our vertex, which we're going to need to put on this graph. And then let's go ahead and get some of the other points here. So if we have to graph this equation, we might as well just go ahead and do that on our calculator. So we go to y equals, and we're going to go ahead and put in the negative 8. And you could put in x, or you could switch that to a t if you really like, but x is fine. X squared plus 40x plus 5. And then I'm going to go ahead and click graph here. And you're going to see it goes up really high and then comes down. So I'm just going to actually read off my table in this case. Oh, you know what? I set this earlier. Let's fix that. Okay, so when you pull up your table, it's most likely will look like this. And we have a bunch of points that we can graph here. So let's go ahead and actually do this. Now, we know that our max point here is at 55, and as you can see, it goes up to 53 on the calculator here. So for our height, why don't we go up by like 5s or something? So we'll go 5, zoom in a little bit here. 10, 15, 20, 25, 30, 35, 40, 45, 50, and then 55. And why don't we do every other? So 1, 2, 3, 4, and 5. Okay, and obviously we have 0 here. So if we look at our graph here, we have a point 0, 5, then 137, 137, Then we have 253. And then we had 353. Looks a little high, but that's okay. 437. And then 5, 5. And then we want to put our vertex point on there as well, which was that 2.555. So our graph will look something like that. All right, so there's our graph here. And then the last thing, it wants us to explain the meeting of the vertex in this point. Well, we're dealing with him launching a ball into the air. So what we're saying by this vertex point is in 2.5 seconds, it will reach its max height of 55. So in 2.5 seconds, the ball will reach its maximum height of 55 units. Okay, and there you go.